Good morning, everyone. My name is Patel Prince Kumar, and my ID number is 24CH073, and I am from CSPIT Department. Today, I will be talking about digital electronics in control systems, a virtual topic that lies at the heart of modern technology. Digital electronics in control system. Control systems are everywhere, from home applications to complex industrial automation. At the core of this system is the ability to process information and make intelligent decision. Role of digital electronics. This is everywhere. Where this is where digital electronics comes into play. It enables control system to be faster, more accurate, and highly efficient. From microcontrollers to sensor and process, digital electronics power the intelligence behind automation. Introduction to control system. A control system manages commands, directs, or regulates the behavior of other devices or system use control loops. This means a control system helps operate all control other devices. It decides how a system behaves using something called control loops, like a set of instruction that keeps things working correctly. Open loop. Second was your open loop. Open loop system lack feedback. Control action is implement of the output. In open loop system, there there is no feedback. The system does not check if the output is correct. It just follows the input. For example, a microwave runs for the time you set whether the food is hot or not. Third is closed loop. Second one is closed loop. Closed loop system use feedback. They automatically adjust to achieve the desired output. That means closed loop system are smarter. They use feedback to check other output, make changes if need, like an air conditioner. It checks the room temperature and adjusts itself to keep it comfortable. Our third page is introduction to digital electronics. Digital electronics use digital signals. These represent information as direct discrete values. Mm, Digital electronics use digital signal. This represent information as direct values. Okay, that means so instead of continuous signals like in analog system, digital electronics work with values like 0 and 1. This makes them more reliable and easier to process. Uh, Logic gates, flip-flops, and counter. First one is logic gates, perform basic logical operation. Second is flip-flops, store binary data. Counter means counter events or pulses. Our four pages role in control system. Digital system enhance control systems. They provide accuracy, stability, and flexibility. Basically, digital system help control system work better. They make them more precious, steady, and adaptable. First is signal processing. Digital electronics process signals. They control outputs using algorithms. It's mean they handle input and decide what the system should next using logic, accuracy. They reduce errors through precise digital control. That means digital control helps avoid mistakes and keeps things running smoothly. Flexibility. Digital system adapt to changes condition. They can that means they can adjust themselves when something changes. That makes them very reliable. Okay. Our next slide is analog versus digital control system. This is most important. Analog. That means uses continuous signals. Digital means uses discrete signals. The next is advantages of digital: better noise resistance, high precision, easier programmability. Our next page is digital control system components. Components of digital control system. First one is microcurrent controllers. The it is execute control algorithms. Second one is digital sensor, measure system parameters. Third one is digital actuators, it converts signals to action. Fourth one is feedback loops, it is adjust system behavior. Our next slide is digital controllers in control system, PID control. That means one of the most common digital controllers is the PID controllers. PID stands for P means proportional, I means integral, and D means derivative. Okay. Proportional means reacts to the current error. I integrals, I means fixes long term accumulated errors, and D stands for derivative, that means predicts and smooth out of future errors. Together, these components make sure systems are stable, responsive, and accurate, used to everywhere from robotics to automotive systems. Our next slide is digital signal processing, DSP. DSP, we have digital signal processing on DSP, which is key in filtering and improving signals. It works in three stages. First one is filtering. Uh, we can see in video. Filtering means removes unwanted noise. Second one is sampling. That means converts analog signals to digital form. Third one is DSP, crucial in application like audio processing. Third one is processing, that modifies and analyzes the signal to make it useful. DSP is crucial application like audio processing, medical devices, and telecommunication. Our next slide is microcontroller in control system. This is slide focus on microcontroller, which are the brain behind a digital control system. They make a real-time decision based on the data they receive. They are everywhere, from robots to washing machines. Let's talk three common types of microcontrollers on here in pyramid. At the top, we have Arduino. Arduino is a beginner friendly and widely used for prototyping and educational purpose. Second one is in the middle is Raspberry Pi. Now, technically, Raspberry Pi is a more of a signal board computer, but it is used like a microcontroller in many cases. Third one is a PIC. PIC controller are used in many industrial and commercial applications. They are known for their efficiency, speed, and reliability. Okay, our next slide is digital communication. Let's talk about digital communication, a key part of any control system. In control system, sensor, microcontrollers, and accurate actuators all need to talk to each other. Other communication happens through protocols, which are just rules for how data is sent and received. First, first one is I2C. I2C stands for Inter-Integrated Circuit. Okay, I2C is greater for simple and short distance communication. It only needs two wires, SDA for data and SCL for clock. It is often used for connecting temperature sensor, displays, or EEPROMs to microcontrollers. Next is SPI. SPI stands for Serial Peripheral Interface. SPI is faster than I2C and also great for short distances. Third one is CAN. CAN stands for Controller Area Network. This protocol is used in automotive and industrial system. CAN is very robust and reliable, especially over long distances. Our next slide is feedback and control digital system. What is feedback control? Feedback control is all about keeping system stable and accurate. It works by continuously adjusting outputs based on real-time data and correcting any errors along the way. Next is digital processing. Digital systems key role here, the process feedback signal quickly and accurately, making sure the system stays on track. In short, digital feedback loops help maintain consistent performance and everything from robots to thermostats. Our next slide is real-time processing needs. Real-time. Control system need real-time processing. Response must be timely. Digital. Second is digital electronics. Digital electronics ensure timely response. They react to changes. Examples: robotics and automotive application require real-time control. Our next slide is robotics or digital control system case study. This means the slide is showing an example of how digital control works in robotics. Section 1: digital sensor. Robotics arms use digital sensor. That means digital sensor collect information from the environment like position, temperature or pressure. In robotic arms, these sensors help the robot understand what is happening around it. Section 2: digital ac- actuators. Robotics arms use digital actuators. That means actuators are devices that create a movement in robots. Digital actuators move parts like arms or fingers. They respond based on the data received from sensor. Third part is microcontrollers. Microcontroller manage feedback loop. Microcontroller manage feedback loop means uh, microcontrollers are like the brain of robots. They take information from sensor, decide what to do, and send commands to the actuators. Next slide is digital HVAC system regulation. First one is temperature controller. That means digital controls regulate temperature precisely. Second one is energy efficiency. HVAC systems optimize energy use. Third one is cost saving. Digital controls save on operation cost. Our next slide is automatic control system. Uh, this means automatic control system use digital technology to improve how cars run. Engine control system save fuel, while braking system make the vehicle safer. At the same time, digital controls boost overall performance, making the ride smoother and more efficiency. Our next slide is digital electronics and their advantages. This means advantages of digital electronics. We can say digital electronics offer many benefits. They are highly accurate and precise, and also very robust, meaning they resist noise and interference. They are flexible, making it easy to integrate with other systems. Plus, they are adaptable with programmable features for different needs. Our next slide is challenges and implement. Challenges implement in mainly three divide. First one is setup cost, high initial expense. Second one is complexity. That means complex design work. Third one is power use, energy consumption. That means running the system use a lot electricity or other forms of energy that is can make it expensive to maintain and may also raise concern about environmental sustainability. Our next slide is future trends, AI and IoT. First one is artificial intelligence, AI in control system. Second one is machine learning, predictive control. Third one is Internet of Things, IoT integration. It means uh, our next slide is industrial impact and technologies. Industrial, first one is industry revolution. Manufacturing had or main smarter or faster. Transformation of industrial through mechanism, electric power, and now smarter automation. Each industrial revolution has brought faster, more efficient, and intelligent manufacturing system. Second one is emerging tech. Modern industrial FPGAs, real-time system, or cloud used mainly. Our next slide is emerging technologies. First is FPGA use. FPGA stands for Field Programmable Gate Arrays. Enhanced flexibility. They allow for rapid prototyping and customization. Second one is real-time controller. That development of real-time digital control improves responsiveness. They handle time-sensitive text efficiently. Third one is cloud and big data. Integration with cloud computing allows for remote monitoring, big data enhanced system analysis and optimization. Next slide is conclusion of our PPT. Now we discuss conclusion. What is the conclusion? This slide is on conclusion of my PPT, digital electronics in control system. Digital electronics have made control system faster, more accurate and reliable. Microcontroller and digital sensor enable efficient automation and feedback. The shift from analog to digital devices devices and like robotics and smart devices rely on control system. Future system will be even smarter and more energy efficiency. Our next slide. Thank you everyone. Thank you all of you for my listening. I hope you understand the topic and found it interesting. Presented by name Patel Prince. My name is Patel Prince and my ID number is 24CS073. Thank you.